All right, and hey, seems like we just left each other, at least to me. What I want to talk about here is factoring by grouping. This is a specific method of factoring that we end up with, allows us to end up with two um, binomials, as at least the way that we're going to do it. So just pay close attention to this, and we will get through it together. All right. So let's say I have 8y squared minus 12y plus 10y minus 15. And you look at this, and we start trying to find a common factor. There's 8, 12, 10, and 15 only have a common factor of 1, and not all of those terms have a y in them, so there's not a y to pull out. So technically, just doing this the way that I've shown you so far, we wouldn't be able to factor anything. However, we do something called grouping. So when I look at this, I can see that 8 and 12 will have a common factor. Y squared and y have a common factor. So I'm going to put parentheses around those. Okay. And I'm going to write up here my original, just to make sure that you don't get confused and I don't get confused. Okay. And then I look at the next one. 10 and 15 have a common factor, right? And so I'm going to put parentheses around this. And what I'm going to do then is treat these as two separate polynomials that I'm factoring, and then we'll bring them together. So first of all, the common factor between 8 and 12, well, common factors are 2 and 4, right? And 1, of course. So we're going to say 4. And y and y squared, you always take the variable with the smallest exponents. This says y to the first, so it's y. So I'm taking the 4y, factoring it out, which means 8 divided by 4 is 2, y squared divided by y is y. And then minus 12 divided by 4, which is 3, y divided by y is 1. We don't have to write that there. And so this is our first side here, factored. And then I put a plus sign here. Put a plus sign here. And I'm going to factor out the common factor between 10 and 15, which should, right away, you should realize that's 5. Right? So I'm going to factor out the 5. And there is no common variable, right? So that's all I got. So 10 divided by 5 is 2, and I get that y there, minus, and 15 divided by 5 is 3, so I get 2y minus 3. Now, I want you to look at this, right? Look at it very closely, and you will notice that much like this problem that I did in a previous video, all right, now I have, right, a common factor of 2y minus 3 in each of these terms. So I've come a little bit of a ways to get there, but then I'm going to take that 2y minus 3 and factor it from each term. So I'm just going to write it by itself. And then what I have left is 4y plus 5. That's what I have left. And that is factoring by grouping. This is now completely factored. Now, I do want to point out that you should be able to put all this back together and end up with this 8y squared minus 12y plus 10y minus 15. So let's look at that and see if that's actually what happens. 2y times 4y is 8y squared, right? And 2y times 5 is 10y. And negative 3 times 4y is negative 12y. And negative 3 times 5 is negative 15. So I just foiled this, right? And what do I have? Well, I don't know. Is this the same? If you think about it, if we apply the commutative property of addition, then yes, because this can be rewritten with this over here and this over here, right? So we get 8y squared minus 12y, right? Plus 10y minus 15. Now, would this have worked otherwise if we had grouped things differently? That's a very good question that unfortunately, well, actually I do have a good answer for, because if, let's say I had this, instead of negative 12y plus 10y, I had it written this way to begin with, and I grouped it that way. So let's say I grouped it this way. Now, plus, and this is going to be negative. Now here's the thing, is I'm going to either make this negative 12y in parentheses, but I really don't want to do that. So I want the parenthesis to go here, right? And minus 15. And then what do I get? Well, first of all, common vector here is 2y, right? And what do I have when I take that 2y out? I have 8 divided by 2 is 4, and then y, 10 divided by 2 is 5. I want you to look up here and see this, 4y plus 5. So we've got the same thing occurring down here. Let's see if it continues. Minus, and then I have 12 and negative 15, and again, this is going to be 3 that I'm factoring out of this, right? And I get 4y plus, factoring out 3. Excuse me. Well, so this is why maybe I should have left this inside here, right? So that should have been inside there. That's a little sloppy now, but 4y plus 5 here, because we factored out negative 3 out of both of those. And what do I get here then? 2y minus 3 and times 4y plus 5. So I get the same answer. So in this case, it didn't matter what order those center terms were in, and what we paired with what, right? So there you go. And I'm going to be making some more.